Well, so far we have taken all of our expressions and expanded them or made them larger, so to speak. Now I want to go in the opposite direction and I want to condense my expressions. Well, I'm going to condense them as much as I can, and I'm going to do it using kind of the similar process from what I had done before. Remember, I had this kind of set of procedures that I used in order to expand my expression. Well, I'm going to use the same concept, only I'm going to go up from the bottom. I'm going to start with the power rule and then move my way up this set of procedures in order to take this expanded expression and condense it into a single expression, which is what I want to do. So the first example here says the log of 3x plus 7 minus the log of x. In order for me to condense these into the same expression, or a single expression, we first have to be talking about the same LOGs, or the log has to be to the same, and in this case it is. So now that I know that I have that scenario going on, notice what we have here. We want to apply the power rule. The power rule basically is allowing me to take anything in front of my log expression and bring it up into the power position. Now this is a minus sign, and so it's kind of indicating here, if we follow along with our power rules, that I can bring this up, this -1, so to speak, up here into the exponent position. So I have the log of 3x plus 7 plus the log of x to the -1. Now we apply the product rule. Remember, the product rule says that if my log term is the exact same, then I can write it as a single argument, 3x plus 7 times x to the -1. So I just am multiplying these two terms together here in this argument position. Now I apply the negative exponent rule. In other words, I'm going to take this portion here that has the negative exponent in it, and I'm going to move it down into the denominator, because when I move the position of the base, it changes the sign of the exponent. So this is 3x plus 7 in the numerator and x in the denominator. And that's one way that you could condense this expression. Okay, let's look at the next one over here. I have 1/3 natural log x plus natural log y. So if I am going, starting with the power rule, again, I have a coefficient here in front of my ln of x, and so when I rewrite this, it becomes the natural log of x raised to the 1/3 plus the ln of y. Then we apply the product rule, which allows me to write these two arguments as the product of each other, so the natural log of x to the 1/3 y. I can't do anything else as far as simplifying or condensing this any further, so at this point I now take it out of its rational exponent here and I write this in its radical form. That's what I'm going to do by simplifying it. So I have the natural log of, so we're kind of going backwards from what we've been doing previously. This term, or this value here, x, goes underneath the radical sign. The denominator is the root, or the index, I mean, so it comes out here. So this is the cubed root, and then the numerator is the power underneath, which we don't usually represent that as a 1, but that's what it is. So it's the cubed root of x times y. And that's my condensed form of this particular expression. Okay, let's try one more together, and this time we have something that might be a little bit longer. So I have a lot going on here. I still have 3 terms. Notice in this first set of terms, I have a 1/3 outside of that set of parentheses. So we're going to use just the distributive property to take 1/3, get rid of the parentheses here, and then rewrite what we've got. So this is going to be 1/3 log base 4 of x minus 1/3 log base 4 of y. That removed the parentheses there, plus 2 log 4 of x plus 1. Now that I have kind of distributed the 1/3, we're going to apply the power rule. So these coefficients that are in front of each of these log expressions are now going to move up here into the exponential position, right? The power part. So this is going to be log base 4 of x to the 1/3 plus log base 4 y to the negative 1/3. Notice that negative 1/3 is going to pull up here, plus log base 4 x plus 1 raised to the second power. So it's this entire argument right here in this particular expression that gets raised to that 2. Don't forget that part. Okay, now what can we do? Well, I'm going to apply the product rule. So each of these three expressions are going to become one single argument with a log base 4. So this is x to the 1/3, y to the negative 1/3, and x plus 1 quantity squared. There's my single argument. And at this point, I am going to take care of my negative exponent by moving it into the denominator. So this is the log of x to the 1/3 x plus 1 squared divided by y to the 1/3. All of that is the single argument, right? Because the negative exponent moves this term, or the base y, down into the denominator, and it changed it to a positive. I cannot do anything further as far as condensing this or rearranging the position of anything, so it's at this point that I'm going to take these rational exponents and rewrite it in its radical form. So this is going to be the log base, oops, that's a 4, log base 4 of this term right here. Remember that this is the cubed root of x times x plus 1 quantity squared divided by the cubed root of y. And that is the condensed version of my log expressions that we started with, and it's also been it's put in its simplified form.